So we want to graph these three lines on the same graph. We want to label them line A, line B, line C. If you have different colored pencils or pens, a good time to use them right now. Line A, let me go with red. Okay, so it's in y equals mx plus b. It crosses at 1. It goes down 2 over 1, 2, 3. Put a dot there. You could even use that pattern of down 1 or down 2 over 3, but backwards, over 3 up 2 over 1, 2, 3 up 2 to extend the line in both directions as far as you want. Now we know that both of these lines, this line continues forever, so we put arrows on them. Everybody should know how to do that from Algebra 1, right? Let's graph line B. Line B, I'm going to go in blue. Y equals -2. So that's easy to graph. You simply go to the y-axis, you go to the -2 value, and you draw a horizontal line right through it. Okay? And it goes from one side to the other. Yes, the blue and the red do cross each other. They intersect. But that's not the point. Now let's go for line C in green. This one crosses at -3, and you go up 4 over 1. Up 1, 2, 3, 4 over 1. Put a dot right there. And you could continue to go up 1, 2, 3, 4 over 1 if you wanted to. You could extend it as far as you want. I'm just going to stop right there, but I'm going to put an arrow like this. So we have our, and also an arrow in this direction as well. We have our three lines, our three graphs. Might as well extend it further. And we're done. Everybody should know that from Algebra 1. Now, I wanted you to do this. That way you could take a look at this piecewise function over here, which is composed of the same three functions, but we're just going to be looking at pieces of it. Okay, that's what piecewise functions are. So a lot of us are like, oh, piecewise functions, I'm so confused, I don't understand what's going on. If you know how to graph lines, you should kind of know or should be able to understand piecewise functions. So let me give you an example. Let's ignore all the green line and the blue line. Let's just look at the red line. And let's say if I told you, look at this red line on your x values that are less than or equal to 0. Okay, less than or equal to 0. Now, check this out. That would mean, like, go ahead and get a piece of paper, any other piece of paper, and you could cover up the red line and just show the less than or equal to 0 part. So here's my piece of paper. So if I'm looking at my red line and the condition was if x is less than or equal to 0, well, then I'd cover up all of this, I'd erase all of this, and just show this piece. That's the piece that I'm looking at, the less than or equal to 0 part. X is less than or equal to 0. Why is that? Because we're looking at the x number line. Less than or equal to 0 is that way. Now, what if I would say, look at the red line, but only look at the x is greater than or equal to 0 part? Well, then you would look at the other side of it, right? Okay, so you would just be looking at this red part of it. Or let's say I told you to look at that red line, but look at it from the x value of -3 to the x value of -1. All right, so from -3 to -1. That would mean that I need to cover up this piece over here, -3 to -1, and this would be the segment, the piece that I'm looking at. So the condition is just telling you what piece you're actually looking at of the line. So it all depends which line we're looking at and what condition they want. So like if I told you, look at the blue line, but less than or equal to -3. All right, if I told you that, look at the blue line, less than or equal to -3 on the x. X has to be less than or equal to -3. Then you would just cover up all this, and this is the only thing that you would show. This is the less than or equal. Here's -3, less than's that way. So this is the only part of that blue line that you'd be showing. Does that make sense? I hope it does. Let's jump to the next part, which is graphing the piecewise function. I apologize because for some reason this didn't come out up here. But anyway, we have the same three functions, all right? Let's look at them. The y equals -2. This is saying y equals -2. Remember, f of x is the same thing as y, so y equals -2. So y equals -2 we're going to do in blue. Whoops. Blue. Y equals -2/3 x plus 1. Y equals -2/3 x plus 1. We're going to do in red. So I'm just going to put a little red dot right there. Well, maybe not there. I'll put a red dot right there behind the 1. And the y equals 4x minus 3. Y equals 4x minus 3. We're going to do in green. That way you guys could clearly see what we're doing. So let's graph that first one, y equals -2. So you go to your y-axis, you go to -2, you put a dot there, you draw your line. If you have a pen, don't do it with the pen. Do it with the pencil only, okay? Because we're going to be erasing, because we have a condition right here. They only want us to show what part of that blue line. How about this? Am I going to be showing the left part of the blue line or the right part of the blue line? Left. It says less, so you're going to be showing the left. And we're going to be looking at the location of 3 on x. So here's x, here's 3. I'm sorry, -3. Here's -3. And you only want to show this part of it. So you only want to show this part of it. Now the question is, if I did cover this up at -3, would this be a solid dot or an open dot? Open dot, because it doesn't have an or equal to. So let's put an open dot there, arrow this way, and let's erase the rest. Again, we said open dot, going this way. You could even go off the graph if you want. Now let's move on to the next piece. The middle piece says y equals -2/3 x plus 1. And of course we have a condition. We want from -3 to 0. So let's go to y equals -2/3 x plus 1. It crosses at 1. And I'm supposed to go down 2 over 1, 2, 3 and put a dot here. And I could use that pattern backwards. Going backwards 3 and up 2, put a dot there. And I'm supposed to draw this whole thing, but you're going to have to erase, right? Because the condition says between -3 and 0 on your x. So if I wanted to show between -3 and 0, that's the only piece of the red line that I want to be showing. Does that make sense? Okay. Now the conditions, they both have or equal to's. So what does that tell you about the segment from -3 to 0? They both have or equal to's. They're both going to be solid dots right here. Okay, so let's show this piece of it with solid dots, and let's erase the rest. And the solid dots are already there. That's great. And now let's move on to our final piece, which is 4x minus 3. I want to do that one in green, stay color coordinated. It crosses at -3. I do go up 1, 2, 3, 4 over 1, and I could continue to go up 1, 2, 3, 4 over 1. And I could go, if I were to draw this, if you have a pen, don't do that. But what's the condition? That your x value is greater than 0. That's what it says here, if x is greater than 0. So go to your x-axis, go to 0, and only show the greater part of that, which means the right side. Okay? So you're going to start right here, and is it going to be an open dot or solid dot right here? Open, and you're going to be going to the right because it says greater. Okay, so let's go back and erase the bottom part of it, and let's put that open dot right there. Put an open dot right there, and we're good. We have graphed the piecewise function. I don't know, what do you think? Is that a little easier, more understandable than yesterday? Yes. I hope so. Okay, I hope so. Now there's more to it though. We are going to have a quiz on this tomorrow, but it's going to be fairly easy, especially if you pay attention and practice the worksheet with the worksheet today. But there's going to be a little more to it. On the quiz tomorrow, I will ask you to give me like a f of, and let's pick -3. Okay. Now that notation means that I want you to plug in -3 into the f of x function. Yay? Yeah. You could do it with algebra. Like, where would I plug in -3? Would I plug it into this top one? No, because -3 is the x, and -3 is definitely not less than -3. It's equal to. Would I plug it into the middle one? Yes, because -3 really is equal to -3. I can't plug it into the bottom one because -3 is not greater than 0. So the conditions tell you where to plug it in. Does that make sense? Okay. Now, if you already graphed it and you did it correctly, you don't have to plug in anything. You could just look at your graph, and if this is your x value, all you got to do is find your corresponding y value. Because what are you going to do with this -3? You're going to plug it in, to wherever you need to plug it into, and you're going to work out the math, and you're going to get a y value. You're going to get an output. But if it's already graphed for you, you could do the input of -3. What does it give you? Does it give you a +3 or does it give you a -2? +3. So the answer is, to f of -3, it's +3. So you could do this without doing any math. Now let's say you didn't have this graph. Then you'd be forced to say, okay, I need to plug in -3 somewhere. Oh, -3 is equal to -3. That means I'm using this middle one. Then you'd have to rewrite that middle one, -2/3 x plus 1. And you would be plugging in the -3 right in there. And you would have to do the math over 1. And then we could say, okay, multiply the top with the top and the bottom with the bottom. And you could say -2 times -3 is +6, and then 3 times 1 on the bottom is 3, and then you have the +1 at the end. That's going to be 2 + 1, which equals 3. But since we have the graph already, you could just say, hey, they want me to input -3. Well, these are all inputs and outputs. Let's go to the input -3, which is the x value -3, and you could see the output, which is +3, which is the answer, the output +3. Okay, so let's practice that. Let's go for a simple one. What is f of what's f of 1? Without doing math. 1, right? The answer is 1. The answer is 1. Now, of course, if you mess up on the graph, then that's not going to work for you. But the answer is 1. If you plug in 1, like let's say you wanted to verify that algebraically. If you plug in 1, well, would you plug it into the top one? No, because 1's not less than -3. Plug it into this one? No, 1's not between -3 and 0. You plug it into this one, 1 is definitely greater than 0. So when you plug in a 1 right here, 4 times 1 is 4, and 4 take away 3 is 1. That's how we got the output of 1. Without doing algebra, we just went, okay, 1 on the x gave me 1 on the y. There's a coordinate. Okay, but you're not always going to be able to see it visually like that, right? If I tell you, let's say find f of 5. What would the answer there be? You can't visually see it, but you could then you resort to math and you get the answer 17. What? How'd you get 17? Well, think about it. 5, where am I going to plug it in? 5's not less than -3. 5's not between 0 and -3. 5's definitely greater than 0. Plug in 5 right there. 4 times 5 is 20. 20 minus 17. 20 minus 3 is 17. Get it?
Yeah.
Fun stuff. Let's continue on to the homework, but check this out. Before you do it, the backside has the answers. I know mine's colored, yours is not, but there is a mistake right here. Let's go to this bottom one. Bless you. Let's go to this bottom one, and this x is less than or equal to -2 should not be a -2. It should be x is less than or equal to -3. So everybody please correct that on the solutions on the backside. That way you guys could work and have the correct answers there. It should be x is less than or equal to -3 up there instead of -2. So let's go to the actual homework part. So I'm not going to explain every single one. On this first part of the homework, which is going to be almost like the quiz, the first part of the quiz is going to be exactly like this. We have 3 piecewise functions, f of x, g of x, and h of x. And all you need to do is look at the appropriate piecewise function and then plug in the given input that they want. Remember, this is notation. So g of 5, what that's saying is go to your g function and plug in the input 5. So we don't have the graphs yet, but plugging in 5 would mean, all right, here's g, but do I plug it into the top part, the middle part, or the bottom part? It all depends on where your input lands. Is 5 less than -1? No. Is 5 between +1 and -1? No. Is 5 greater than 1? Yes. So we're going to be plugging it into this bottom part. And when you plug in 5 in here, there's no math to do. That's just your answer, 5. So everybody should write down 5 for number 1. Pretty easy, right? Let's look at number 2. G of 1. Go to the g function again, and you want to plug in 1. Well, where would 1 land? Is 1 less than -1? No. Is 1 between -1 and +1? Yes, because it has an or equal to. It says an or equal to. So 1 does equal 1, so I'm going to be using this middle one. I need to plug in 1 into the middle one, but that middle one doesn't have any x's. So what's your answer going to be? It's just 0. Whatever number it has right there, your answer is 0. Right? Now, if this would have been a 3 right here, then your answer would have been 3. If this would have been a 7 with no x, then your answer would have been 7, because there is no x. So let's jump to, let's go to number 4, f of 0. So I want to plug in 0 into my f of x function. So I would plug in 0, is 0 less than 2? Or is 0 greater than or equal to 2? 0 is less than 2. So plug in 0 right there and do the math. What's 2 times 0? 0. Maybe you do want to show your work. I don't know, 2 times x, put parentheses instead of x. That way you could clearly see that you're plugging in that 0 right in there. So the answer is 0. Let's jump to number, I don't know, pick one. 5. H of negative 4. So we're using the h of x function. We want to plug in negative 4. Is negative 4 less than negative 4? No, so you're not using the 3. Is negative 4 equal to negative 4? Yes, it has an or equal to, so we'd be using this middle one. So I recommend when you're plugging in the input negative 4 into this part, I would rewrite that part. So I would rewrite it as negative 1/2 parenthesis. That way you could clearly see that you're plugging in the x value of negative 4 right in there, and then you do it. So how do you multiply a fraction times a number? It's really easy. Put the number over a 1, multiply the top with the top, bottom with the bottom. And negative 1 times negative 4 is positive 4, and 2 times 1 is 2. 4 divided by 2 is 2. So that's your final answer for number 5. Do we get this? All right. So we're going to just jump to the next section, graphing piecewise functions. Okay, graphing piecewise functions. And they want us to graph the f of x, which is this one up here, the g of x, which is this one up here, and the h of x, which is this one up here. So let's begin with the f of x function. Now it might help you, if you're really confused on this stuff, it might help you to actually draw y equals mx plus, or write y equals mx plus b equations. So check this out. This really says y equals 2x plus 0. So if you want, go ahead and write that. I'll do it in red. Y equals 2x plus 0. That would mean that it crosses the y-axis at 0, and I go up 2 over 1 and up 2 over 1. And you could use that pattern backwards to extend the line as long as you want. But if you have a pen, please don't do this, because you need to be able to erase. Okay. Now, what is the condition of this red line if x is less than 2? All right, so where is less than 2 on the x-axis? I'm going to cover this part up. There's my 2. So here's the x value of 2. That's why I'm covering up the right part of it, and I'm only showing the left part of it because it says less than. They want us to show the left part of it because it says less than. So we're going to erase this part, and because of the less than, it's going to be an open dot right there, going this way. And let's do the other part in blue. So y equals x minus 1, y equals x minus 1. That crosses at negative 1, and it goes up 1 over 1, up 1 over 1, up 1 over 1. And you could draw it. And before extending it to the left, I'm just going to take a look at what my condition is. It says if x is greater than or equal to 2. So greater than or equal to 2 would be the right side of 2. Here's 2 on the x. So I only want to show this part of it. And let me ask you this. This beginning point, is it an open dot or a solid dot? Solid dot. So I'm going to put a solid dot right there. And I'm going to erase whatever other piece I wrote over here, okay? So let me do that. So a solid dot, and erase this right here all the way to 2. And that's a solid dot. So let me put a solid dot right there. And that's it. So I hope everybody understands how to graph these pieces, yeah? Now let's go to domain and range. When they say state the domain and the range of this f of x function, it might be a little confusing. The domain are your x values. So does this graph, which has 2 pieces to it, does it go to the left forever? Yes. Does it go to the right forever? Yes. So in terms of x values, because we're talking about domain, you're going to say x equals all real numbers. You got to make sure that there are no holes, right? What do I mean by holes? Or any missing gaps, right? Like this is continuous, and then there's an open dot here, there's a solid dot here, so there is no hole, right? If this would have been an open dot, then you'd have a problem. Your domain could not be 2 if it were an open dot, but it is continuous. And there's going to be some other ones where it's not continuous all the way. But in this case, the domain is x equals all real numbers. How about the range? The range are your y values. And right here, y is going up and down. Does this graph or any piece of this graph go up forever? Yes. Does it go down forever? Yes. So what do we say about the range? All real numbers as well. Okay, let's move on to the next one. The g of x function. The g of x function has 3 parts. Okay. The first part I want to do in red. If you could look up there, it says y equals negative x, right? Y equals negative x. I'm going to jot it down right here so nobody gets confused. That crosses at 0, and the negative in front of the x implies that you're going down 1 over 1, down 1 over 1. And you could use that same pattern backwards to extend it the other way, but you need to erase the part that you don't want to look at. So let's look at the condition. It says if x is less than negative 1. So go to your x-axis, go to negative 1, and they want you to show the less than part of it, which means you want to erase this part and show just the left side. Does that make sense? So the question is, if I erase this part, what do I begin this with going that way? Is it an open dot or a solid dot? Open dot, because it doesn't have the or equal to on the inequality. So let's erase it and put an open dot at negative 1. Erasing and putting an open dot at negative 1. There we go. Put an arrow right there. Let's move on to the next part of the g of x function, the 0 part. So if I say y equals 0, I could write that down, y equals 0. And graphing y equals 0, graphing y equals any number would be to go to the y-axis, go to that number, and draw a line right through it. But of course, you only want to show the portion that's from negative 1 to positive 1. So that's from negative 1 to positive 1. And you don't want to show any of this piece just from negative 1 to positive 1, and you want them to be solid dots at negative 1 and positive 1. So let me erase this and put solid dots at negative 1 and positive 1. Let's go for the third part. Y equals x. Y equals x. So we know that that crosses the y-axis at 0, and you rise 1 and you run 1, rise 1, run 1. And we know that it goes that way forever. And we also know that it goes this way forever. But we only want to see a portion of it, and that portion is x is greater than 1. So if we cover up from 1, we want to show the greater than part. That's to the right. So this is an open dot right here at 1, and you'd erase all this part of the line. So let me do that. I want to erase all of that, and we said it's an open dot at 1. Now the domain and range could be kind of confusing on this one, because the domain, does it go to the left and to the right forever? Yes, so we would say x equals all real numbers. Now the range is a little bit more tricky because we're talking about the y values. Now the y, this graph does not exist on the negatives, does it? So you can't say y equals all real numbers. Where does it exist at? What would the inequality be that represents that it's above a certain location? Y is greater than, and here's the tricky part. There's a gap. Yes, it's at y equals 0, right? But there's a gap between 0 and 1. There's a gap. So if you want to represent the inequality of the graph going up above 1, that would be y is greater than 1. So you'd say y is greater than 1. But then you say, or y could also be 0. So you have to, that's the tricky part right there, or y equals 0. Because there's a gap missing, right? Let's go for that last one. So that last one, let's graph it. We have in red y equals 3. It's a solid line at 3, totally flat. But we want to erase whatever part we don't want to see. And it says x is less than negative 4. So negative 4 would be right here. and you would only want to show this portion of it. And is it going to be an open dot or a solid dot right here at the -4? Open. So let's go back and erase all of this part and just put an open dot. At -4, put an open dot. And we are pretty much done with that piece. Now we move on to the next piece. The next piece is really like y equals -1/2 x. Y equals -1/2 x. So that one crosses the y-axis at 0, and you go down 1 over 2, and you continue to go down 1 over 2, and you could go backwards with that pattern this way. Now you only want a piece of this blue line, and the piece is from -4 to -2. So here's -4. I'm glad I didn't extend it further this way. It's right there. And -2 is right here. So I really only want to see this piece of it from -4 to -2. Only this piece of it. Does that make sense? So I'm going to erase all of this. Let me erase that. And we need to know if it's open dots or solid dots. Well, at the -4, it's a solid dot. It already has a solid dot. And at the -2, that's an open dot. So we put an open dot right here. And now for the last one, y equals 3/2 x minus 2. So this one crosses at -2, and it goes up 1, 2, 3 over 2. Up 1, 2, 3 over 2. And with the backwards pattern, over 2 down 3, over 2 down 3. And you would draw your line. But let's erase whatever piece we don't want to see. And it says up here that you want your x to be greater than -2. So if you were to cover up -2 and just show the right side of it, because say it says greater than, would this be an open dot or a solid dot? Open dot. So it's going to be an open dot going that way. So we need to go back and erase and make that an open dot. Now this is where it gets funky, because it's an open dot. I mean, that's the graph right there. We're done. But when we say the domain x is all real numbers, is it really all real numbers? It's not -2. So we could say x equals all real numbers, but we need to put something else. We need to say, but x cannot be -2. But x cannot be -2. Why is that? Because like right here it exists, right here it exists, but when you get to here it's an open dot and there is no solid dot down here. It's like an open missing value. So at -2 on the x, it doesn't exist. It's not good. So we're going to say the domain's all real numbers, but x cannot be -2. How about the range? So the range, it's going to be your y values. And yes, this whole graph is above this open hole at -5 on the y. So y is greater than -5. Not greater than or equal to, because it's an open dot, not a solid dot. Okay. So down here, I give you a piecewise function that's graphed, and you want to label it or create your h of x function. So down here, everybody should do h of x, put equals, and do this like ginormous bracket, because we need 3 pieces right here. Okay. And how do we know which way to organize our functions? Let's look at it from left to right. This left to right is this line, and let's go in red right here. It's a line that is rising 1, running 3, correct? That's a slope, rise 1, run 3. If you count, it goes up 1 over 3, up 1 over 3. But obviously they're not showing the whole thing. But if I wanted to write my equation, it'd be rise 1, run 3 with an x right there, and it crosses through the origin. So this is my red line right here, but it would extend this way, but we're not going to extend it that way. But this is my function, so I'm going to say y equals 1/3 x as my first piece. Now what's the condition? What part of this line are we showing? We're only showing the left side of the value of 0 on the x. So we're going to say if x is less than or equal to 0. Why or equal to? Because it had a solid dot right here. Okay? And that's the first part of your graph from left to right. So on this other one, let's do this in blue. What's happening? Well, it crosses at -6, and apparently it rises 2 and runs 1, right? Rises 2, runs 1. Rise 2, runs 1. So I already know what that equation is. It's y equals rise 2, run 1 with an x crossing at -6. I don't even need the fraction 2 over 1. I could just write 2x, and that's what I'm going to write. I'm going to write down 2x minus 6. But now I need the condition that I see here. I don't see a line going forever that way and forever this way. It's only between this, and it's between those x values. What are those x values? It's the x value of 0 and 2. So how do I represent that this graph is between 0 and 2? It's simple. You put the 0 on this side, the 2 on that side, the x right here, and then the inequality is less than right there. Now the question is, are those open dots or closed dots? They're open, so I better leave them without the or equal to. Leave them like this, just regular less than symbols. Let's go for the last one. The last one's easy to graph. The last one would be a horizontal line crossing through the y value of 1, right? So what's that equation going to be? Y equals what? 1. So we're going to put a 1 right here. And what's the condition? What part do you see with regards to x's? Is it the left side of 2 or the right side of 2? Right. So what am I going to write? I'm going to say if x is greater than or equal to 2. Ta-da. Not bad. Now, check out this fun part right here, guys. When on questions 14 and 15, it says state h of -3. So since you have your piecewise function with your conditions, you could say, okay, I need to plug in -3. Do I plug it in right here? Yeah, because -3 is less than 0, and you do the math. Or the easier route is to just look at the graph, especially because they already graphed it for you. And if you want to plug in -3, what would you get out? If your x value is -3, what's your y value? So go to the -3 on the x. Check it out, guys. -1, -2, -3. What's the y value that you have here?
0.
-1. That's the actual coordinate, -1. So your answer to that one, h of -3, the answer will be -1. Now what this is saying is to plug in -3 into here, and yeah, 1/3 times -3 will give you a -1. How about number 15 without doing math? If you look at the input of 2, what do you get out for the output? The y value of 1, because it's graphed for you. It's given to you right there. So that's your answer. H of 2 equals 1. The input 2 gave you the output 1. Now, what if I would have said, let's say h, just for funsies, h of -9. No? Yeah, -9. Let's see what happens. H of -9. Could you use the graph for that? Not really, because if you go to -9, you're going to be way out here, and it's going to be somewhere down here, but you can't see it exactly. So right here, yeah, you're going to have to resort to some algebra, plugging in -9 where it belongs. -9 is definitely less than 0, so you'd plug it in right here. -1/3 times -9, that would give you a -3. So sometimes you actually have to plug it in, but if the graph is there, you might as well try to see the answer on the graph. So I did forget to state the domain and range of this piecewise function. So let's talk about domain. The domain are your x values, which is to the left and to the right. Now, does any of these pieces go to the left forever? Yes. Does it go to the right forever? Yes. Are there any gaps? No, right? This is a solid dot, it's an open dot, that's taken care of. This is an open dot, this is a solid dot, it's taken care of. So the domain is really x equals all real numbers. Let's go for the range. The range are your y values. And you also have to be careful for gaps, right? So does this exist anywhere down here? Yes, this red one will continue to go this way and down forever. So it really does go down to the bottom forever. Does any of these pieces go up forever? No. Okay, so I know that my graph is going to be at this point or below. And how would I say that in terms of y? At this point or below? Y is less than or equal to 0, because we're talking about the y's, right? Okay. Now, some of us would say, oh, y is less than or equal to 1, but there's a gap right here. There's a gap. So we're going to say y is less than or equal to 0, because that implies the red line and everything down here. But we also need to say, or y could also equal 1. Okay. Or y could also equal 1.
What makes it say that it could equal 1?
What makes it say that it could equal 1? The y value, like for example, does this graph exist at y equals 2?
No.
At y equals 3? At 5? No, it doesn't, right? Does it exist at y equals 1? Yeah, it's right here, at y equals 1. Does it exist at y equals 1/2? Is there any part of the graph on y equals 1/2? No way, it's missing. So that's the gap right there. So that's why we say less than or equal to 0, because all of this is at less than or equal to 0, but it's missing this part. So we say less than or equal to 0, but then we throw in this extra single value of y equals 1. Last one. Which function should I start with? Which part of the line should I start with? The one on the bottom left, right? Because you're going to be looking at it from left to right. So what line represents that horizontal line that would normally cross through the y-axis at -2? What is that called? The equation. Y equals -2, correct? Okay. But we want to write it in terms of f of x. So everybody put a f of x down here. Do the equal sign. Do this like ginormous bracket. We're going to put the -2 right there, but let's give it a condition. If what? If x is less than or equal to -3. Perfect. Okay, now let's go for the middle line. I want to do this one in blue. The next line's in blue. It does have open dots, but if I wanted to write this in terms of y equals mx plus b, what would it be? What's the slope? Down 1 over 1, right? Down 1 over 1, down 1 over 1. So my slope is -1 over 1, which I don't even have to write it as -1 over 1. I could just put a negative in front of the x. How about the b value? Where does it cross the b value? Where does it cross the y-axis? At 4. So there's my function, but how am I going to write it right here? Well, it's going to say y equals, I want to write it as -1x, or just -x plus 4. Now I need a restriction, because it's not the entire blue line, it's only the piece that's between this x value and this x value. What is that piece between this x value and that x value? It's the piece between -3 and 0. So how do we write that? We're going to write down if between -3 and 0 is where your x's are at. And of course we put the less than symbols. But if we had solid dots, we would put the less than or equal to. But they're open dots, so you just leave them as less than. Finally, for the last piece, it's pretty easy. And y equals mx plus b, obviously it's going to be y equals 1x, or just y equals x. So on the third one, you're just going to put a regular x. But what's your condition? If what? X is, what part are we looking at? Are we looking at? Yes, greater than or equal to 0. What would the domain be? Does it go to the left and to the right forever? Yes, so the domain, x equals all real numbers. There are no gaps. How about the range? Does it go up and down forever? It goes up forever because of the green one, but it doesn't go down forever. So it kind of starts here and goes up, right? So how do we represent that in terms of y? Starts there and goes up. Greater than or equal to 0. But we also have this extra y value down here. Or y equals -2. Or y equals -2. Perfect. Let's go for these easy questions, especially because we have the graphs right here, number 16 and 17. State f of -2 on number 13. So if you just go to -2 on your x, it would give you +6 on your y. But just by looking at the graph, without doing math, guys, look. F of -2. Let's go to -2 on the x. Where's your coordinate at? It's way up here at 6. So f of negative 2 will give you an output of 6. Now, if you actually did the math, you would have to plug in negative 2, not here, but right here. So you'd have to plug in negative 2 right here. And check it out. Negative 2, that'd be a positive 2, and 2 plus 4 really is 6. But instead of doing that math, you could just look, negative 2, right there, 6. Make sense? How about number 17? What would the answer to 17 be? F of negative 3. So if you go to negative 3 on your x, it's down here, the solid dot. So that'd be a y value of negative 2, an output of negative 2. So when you plug in negative 3, you get an output of negative 2. Just for funsies, what if I said find f of 8? What would that be? Where would you plug in 8? Into the top one, the middle one, or the bottom one? Bottom one. 8's greater than 0. So if you plugged in 8, what would that be? That would simply be 8. So sometimes you can see it on the graph. If you can't, then just use the algebra.